And welcome to the Daily Space Weather. We're looking at the coronagraph at stereo A. And we see another Earth-facing coronal mass ejection here. Right under the recording button there. You see that little piece of plasma? We've got some Earth-facing component in some of the plasma out there. And it does show up on the LASCO C3. We'll get to it in a minute. So lots of stuff to cover, folks. We do see a filament down here in the 131 angstroms view. You can see this filament right here. So a little bit of solar activity kicking off, a little bit of plasma monkeying around and so on. Here's the North Pole view. We see a bunch of coronal holes, and here it is in 193 angstroms. North Pole coronal hole looking large, and it is in charge currently of the current sheet. There's that large, now very well-defined coronal hole just north of the equator, as the more southward one associated with the South Pole, like a zigzag going all the way to the South Pole, is now kind of rotating out a bit. Active region down here is not a sunspot, just a plage, formerly sunspot 2752, I believe was the number. No X-ray flaring going on. And here's the image from the LASCO C3. Now this one is not located at stereo A, this one's located in between Earth and the Sun. And we do see a plasma plume here. So if you look right in that area, showing up at yesterday around 18 to 20 UT, so like around 6 or 8 p.m. yesterday Universal Time, we clearly see. Now this could still miss to the east, as we see more plasma to the east than to the west, and of course it's not a big one, but we do see that is clearly an Earth-facing coronal mass ejection. Nothing to flip out about, folks, but there it is. It's the truth. So cheers. Here's a real-time solar wind, and we're looking at 1 day of activity here. We see the coronal hole wind speed has subsided since yesterday's stream ended, which ended around 2 o'clock. You can see everything dips off here. And we did actually see some recent phi angle shifts too, as we await magnetic connection to that incoming coronal hole. Anyway, solar wind density at 5.63 protons per cubic centimeter. Solar wind density 5.63 protons. Solar wind speed 352 kilometers per second. That's kind of fast. There's the ACE data, looking similarly to me, except for perhaps the phi angle. The ACE picking up the opposite phi angle shift. So perhaps nothing too exciting about that. Here are the geospace magnetosphere movies. We're just going to look at pressure, as there's not a lot going on. Anyway, there's 4 hours of data. By the way, the song you're hearing now is called Dung Beetle and is available all of nowhere. And here's the ground magnetic perturbations, and we do see some magnetic perturbations here. And here they are visually displayed, looking at 4 hours of University of Michigan geospace model data. We got some interesting stuff to cover, by the way, folks. We're gonna be talking about dark doppelgangers, arc doppelgangers. Yeah, as Gareth did a very interesting video about this, and we're also going to be talking about some cosmology. But first, we're going to continue on with some data. 10.7 centimeter radio flux. Still at 70, right on that orange line we've drawn in. Magnetometer, at least the GOES magnetometer. There's the data. Still looking a little choppy, and no real forecast from me on this one. It should be kind of smooth, I would expect. barring some unforeseen magnetic events, which can come out of nowhere, by the way. Which is, by the way, not good news for things like the catastrophe cycle, but we have to report it anyway, since it's reality. Anyway, here's the Gong 2 data, and you can see the current sheet crossing. There is some suspended plasma out there, and that's causing the B field to be pulled down, essentially. KP is at 1. There's the planetary K index coming down from 2, and that was a pretty weak coronal hole wind stream there, folks. I'm going to skip cosmic rays today and move on to the GOES electron flux. And we should see a small increase in this one throughout the day. Nothing very extreme at all. There's the relativistic electrons, which are low to moderate. Ionosphere is looking pretty normal, in my estimation. And part of the reason that we look at this data every day is so that we have an estimation. Here's the latest image. This one coming in at 11:15 UT. And looking pretty normal, really. Here's the silver price, if you were wondering. Looks like it's finally leveled out at 17 bucks. Looks like a significant support level there, just formed at $17 per ounce. And no further comment on that. Earthquake rundown over the past 24. Includes a 4.4 at Indonesia. And another 4.4 at Indonesia, farther north. We've got stuff playing that I don't want playing, folks. All right. Next on the list is a 4.6 at Indonesia also. Big uptick at Indonesia. 5.1 at Indonesia. These are all in different locations, folks. 4.4 at Indonesia. And here's a quake at Chile. And that's a 5.3. That's one of the larger ones we've seen in the past 24. 4.5 at Greece is next. That one coming in at 1815. Here's another Indonesian quake at a 4.5 magnitude. Here's a 4.4 at Honduras. 4.7 at Indonesia. 5.1 at Indonesia. 4.3 Indonesia. Lighten up the list. 4.6 at the Philippines. Definitely the biggest hotspot of earthquakes in the past month has been this area. 4.1 Indonesia, 4.7 Papua New Guinea. Here's a 5.3 at Japan, who probably shrugged off that quake. Here's a 4.9 at Indonesia, a 4.8 at Indonesia. 4.8 at the Solomon Islands. Here's another Middle Eastern quake at depth, 4.5 magnitude, 135.4 kilometers. 4.1 at Indonesia. A 5.8 at Indonesia is the largest of the past 24. That one coming in while we did show prep. Next, we'll look at the volcano rundown. Mount Aso producing a 6,000-foot ash plume. Sakurajima exploding, 10,000-foot plume there. Sanjiang-api exploding, 8,000-foot plume there. Dakono, volcanic ash plume, a 7,000-foot explosive activity. Sangay exploding, 19,000-foot plume there, which I believe is an uptick at Sangay. Please comment if you're following it more closely than we are. Revenador, possible emissions. Sabancaya, volcanic ash not identifiable in satellite imagery. And Nevados de Chilean. It's a mystery. It's going down in history. Here is the planetary situation. Milky Way galaxy team for the win. There's where things will be in 7 days. By the way, while we're talking about spacey stuff, check out some of the structures in this thing. It looks like an X-ray hotspot over here. Look at some of these structures. Is it an obvious spiral, folks? Just saying. Anyway, here's what's going on above my head, I think. Let's hit refresh. Man, oh man, it's late. Is it light out already? Jeez. Doing the video at 6:30. All right. And we're having a planetary pileup as Mars and Mercury have just risen, and the moon is on its way to set. Now, we've decided to study a star every day, and today's winner came from the comment section. So this is why we keep our comment section lively on the channel. Wolf 359. Oh yeah. So we looked up Wolf 359, and indeed, it is the title of an Outer Limits episode, which aired on November 7th, 1964. It is also mentioned in Star Trek TNG and Deep Space Nine, a deeply spaced out show that some of our deeply spaced out viewers probably deeply watch and love. Anyway, it's something to do with the Borg or something. Anyway, Wolf 359 is an extremely faint red dwarf, not visible with the naked eye alone. It's 7.9 light years from Earth. It's very dim. It can only be seen with a large telescope. It's got a low temperature. It's got a strong field. Yeah, it's got absorption lines indicating that it's got things like titanium oxide. So it's it's got a strong magnetic field, and it does emit some flares. It is not on the transients list, as far as I know. I did look it up briefly, but I didn't look for all of its names, as a lot of stars have multiple names. And it is on the list of the nearest stars and brown dwarfs. And if you've got 3D glasses, which is the red-green kind, put them on now, and you'll get a lovely 3D image, courtesy of Wikipedia. We've left links. You can go visit the page if you like. And if you like the original music, well, you can stream it for free, or you can download it. Like, for instance, Molybdenum 99 is only 99 cents. It's a coincidence, folks. If you want to hear some weirder stuff, check out the SoundCloud page. It's pretty old stuff, folks. Pretty old. Here's where the lightning's coming down. Or is it going up? Or is it doing both? Neil Thompson, please leave a comment. lightningmaps.org. Next time you hear thunder, check it out. It's good times. Next is the U.S. Doppler radar. See some heavy storms in Georgia. Shall we zoom in? Well, yes, we shall. Here's the animation of that area. Got a strong counterclockwise rotation going on there, even on the radar map. Let's check some other instruments. By the way, did anybody check out those satellite images? Let's see what's going on in the water vapor map. For all you viewers who were wishing we had live streams, this is what it would look like if we were streaming live. Yeah, we did it on purpose. Anyway, there's that convergence zone going on over Georgia, looking highly electrical in nature, and let's don't even get into it. But yeah, there's some interesting activity. By the way, if you're outside of those regions and there's lightning going off, go look at the cloud tops. Maybe you'll be able to see some sprites, get some photographs, and cheers. Let's go back to wherever we were, which is to say, if you enjoy the content, please press like and subscribe on YouTube. And thanks to our new subscribers, as we've almost reached 1,500. And sorry if we're too abrasive, but there's a lot of things to do, so we've got to kind of focus on what's important. Wait till I start bike racing again, it's going to get hectic. Here's the windy.com pressure map. I'll just let that advance for a little bit. See a heavy high pressure system over the northeast U.S. And check out the high pressure over Asia, the entire continent. Major high pressure systems. Here are the western jet streams, which, by the way, are extremely broken up in the southern hemisphere down there. Look at those areas southeast of South America. Those jet streams are all over the place. Those jet streams are bonkers. That is some funky weather. Please leave a comment if you think that's caused by carbon dioxide. Some backwards jet streams there over the Middle East, causing it to be really quadrupled in that area. Let's look at the full northern hemisphere. And the jet streams are all over the place, folks. All over the place. By the way, we are planning on having an Ask a Pilot segment coming up soon, where we prefer our viewers to understand the distinction between their you-know-what and a hole in the ground. We go vulgarity free and we talk about whatever we want. Well, what we want to talk about is this course here by Jim Weninger from Electric View. Viewers, go check this one out. It's talking about the local chimney, etc. Let me just play a clip of Jim here. Shout out to Jim and Electric View crew. Just play a little clip as a teaser and recommend that everybody go watch this video in its entirety. It is an hour long. It's well worth it.
You might think that they would have drawn, if this is the sea, they might have drawn Argo here, but they...
He's talking about the way ancient symbolism is reflected in observed cosmological phenomenon. Now, let's talk about Gareth's video. I believe this went up yesterday. He put this in a photo editing software called GIMP, and he checked to see what was going on. Is this a fully inverted lens image where it's flipped horizontally as well as vertically, or is it a reflection? And he noticed that these spots were indeed reflections. Let's just play a clip here. Again, we're going to be just a couple seconds of clip here. Please don't ban us.
Decrease its size. And again, this is a little bit of trial and error.
Anyway, he goes through to show that there is some repetition of images here. It's not clear which portions of this lensing phenomenon are showing up, but it does look like a circle within a nested circle. And I also wanted to note the fact that we did leave comments here, which I'll read for the viewers. First of all, agree with you on this one, Gareth. We know electromagnetic fields affect light in major ways. In a laboratory, light has even been stopped entirely in an intense magnetic field. There's no question that a magnetic field can bend light. There does not have to be any distortion in, quote, space-time, end quote, to produce the effect. And when we send radio signals up to refract through the ionosphere, people think that they're bouncing off the ionosphere. Those signals are actually refracting. They're being bent. It's not the same as a reflection. All you need is a strong electron belt, and you should be able to produce the effect in the laboratory. Gravity needs not apply. So we've got links to both of those videos. They're important cosmology videos, especially when referring to things like the electric universe, gravitational lensing, gravity running the show, and so on. Again, please press like and subscribe on YouTube. By the way, this was supposed to be a smAsho stream, but it didn't work out that way. Thanks, patrons, as you are the associate producers of these videos. And check us out there. viewers. Patreon.com/smAshomash, the real source of funding for this channel. And thanks, Smash Team. Stay tuned for bonus features. QuakeWatch.net was mentioned in the comments yesterday. Check that out, as there are methods to predict earthquakes that are not mainstream at all. And perhaps follow Ben Davidson's Twitter, which is at TheRealS0S. And this, you're going to see all kinds of stuff about their earthquake forecasting and so on. So perhaps follow that, as you get pretty regular tweets from Ben. Again, we don't really tweet. We are considering using Gab this winter. It's going to happen, I think, but we'll see. We'll see how it works. We're not going to cover our mission today, but there are links to it in the description. And we'll close things out with the final bonus feature, which is the 171 angstroms view. Look at the north first. A little bit of filamentary behavior there. Nothing really to write home about. Equatorial view. And let's see if we can see that filament. There was a filament that we could see in 131 angstroms right in this area. Not really showing up. I do see a little bit of a splash like of a feature going on there. Anyway, there's the active region and so on. Thanks for tuning in, everybody. Thanks for staring at the sun. Remember not to drink when you do so, and if you do, don't drive. Really, seriously, don't drive. As I could be out on the road and I don't want to see you there. And since it'll never be now again, may that solar wind be at your back and that atherosclerosis absent from your veins.